So welcome to the Conquering Every Layer of the Mesh webinar. Like I said, my name is John Osborne. Here's some contact information, and don't be bashful. Feel free to send me an email, hit me up on Twitter or on LinkedIn. Not a problem. So as we talk about Mesh, these are the four kind of ways that I want to walk you through the webinar. So first is a quick overview of Mesh. I say quick because Mesh is a deep topic. It can get very academic. It can be very detailed. I'm not trying to cover all of that here in the 20 minutes that we'll spend talking about it, but I do want to make some salient points and focus in on a few things that Mesh brings to light for you. I also want to talk briefly about why is Mesh a topic? Why do people care? Why are we even doing a webinar about Mesh? We'll talk about that for a few minutes. And then I like to move into some more practical Mesh discussion. So one is Mesh working for you? So if you go down the Mesh route and you go to execute a Mesh strategy, how do you know it's working? What are some ways to work with that? And then what kind of issues might you run into in your organization around Mesh and how to avoid those? And then of course, this being Ascend webinar, I want to talk through how Ascend brings some solutions to very complex Mesh problems that almost everybody runs into for sure in Mesh and drive some excitement there. So hopefully you'll get a ton out of it. And what I'd like you to leave thinking about is that Ascend is an option for you if you're going to invest in Mesh. And it's an option in contrast to potentially the only option you had a few years ago, which was to build something. So Ascend is a quite compelling purchase offering. So if we were to break Mesh down into its core components, as you may or may not know, hopefully people who are interested in Mesh have done some reading. It is a platform architecture that allows us to decompose our data into domains that we call business data domains. These domains match up fairly well, if not perfectly, with our business domains, in that if the business has a concept of a customer or has a concept of a shipment or a product that they sell, that those concepts end up becoming domains in the data space. And we call them domains because what we're doing is building a bounded context around these things. So we're moving away from a monolithic architecture where I have a single data model for everybody, and I'm moving toward a data architecture where I'm breaking down business domains into technical domains that we can accelerate with. Along with Mesh, these three other things are super important. One is the data product mindset is a key feature of Mesh thinking. And what we mean by product mindset is that we're taking customer feedback into our data products that we're producing. So if a product is missing something, let's say you have a customer and people for whatever reason need middle name information and you're not supplying that middle name information, a data as a product mindset would then take that feedback from your customers, distill it down into some meaningful product update, like adding a middle name, for example, to your customer domain, and then publishing that data and doing the change management and letting people know, like, hey, we've upgraded our product. Here's some changes we've made. So this data as a product mindset drives a feedback loop between customers and data delivery, and it makes in particular engineering teams very sensitive to how their data is being consumed, how easy is it to consume, how understandable is it. And this product mindset can drive lots of efficiency into systems, even without changing technology. I'm a fan of product mindset, regardless of your implementation strategy. The data mesh also, obvious or not, drives or attempts to drive or gives you a framework to drive a self-service data platform. I think for many years, we've heard terms like data democratization and things where in these terms where what we're trying to say is we want people to come use our data. We want to offload some of this work that we traditionally have given to engineers, and we want people to come and self-serve themselves in meaningful ways, but also in ways that are decoupled from our core engineering functions so that those those core engineering functions can deliver value and not necessarily be distracted with questions that can be self-serve oriented. So data meshes are very much focused on driving a self-serve platform, and there's a lot to go into there, and hopefully we'll cover some of that today. And then the last topic is a governance model. Lots of monolithic data architectures have governance models, but those governance models track with the monolithic architecture in that they're centralized, and you have like a central control point where the governance is happening. These tend to be maybe slower or not as agile as we'd like them to be. Mesh is going to come with a more federated model in that the governance can be distributed, like the data can be distributed, and we can drive some agility into governance, but then also apply some better governance strategies for describing data as a product and consuming data as a product. What are our security standards and what are these things? And not that you can't do that in a monolithic architecture, but as you move to a mesh architecture, governance is a critical piece of that. So it's important to keep that top of mind, if not in the shift it left in the design process, for sure. If we were to go and look at Zhamak Dehghani's work, who's essentially the creator of data mesh term, or at least she's credited with the data mesh terminology and pulling together these concepts of the bounded context with data product mindset and building the mesh architecture. If we look at the depth of work that she and other people at ThoughtWorks and other people in collaboration with them have done, we can see that the data mesh looks very complex. So if this is out of one of her publications, we can see that there's lots of endpoints here. There's different places where we do different work, and there's a lot of complexity here. So understanding, what network addressing needs to happen versus query engines and those types of things, these end up being very complex architectures to actually implement, and you end up with something that's academically verbose as far as how this canonical architecture is described amongst lots of papers. Definitely, if you haven't done research in this amount of research in mesh, read some of the ThoughtWorks papers that Zhamak and others have published. They're really useful and detailed. However, they come with this intellectual burden that I know I've read through and scratched my head on a few things and trying to wonder how much weight to apply to these types of endpoints, which ones matter more and which ones do I want to do or not do, and that kind of thing. One of the things that I love about Ascend is that we have a product that breaks down the delivery of mesh into much simpler terms. So as much as we'd like to execute all of these as the recipes would say a mesh should execute them, Ascend as a product has been around now for going on 8 years of time, 5 maybe years or so of engineering incubation, and now some publicly available products for the past couple of years. But Ascend breaks down our architecture into these 3 areas where meshes can be built and applied very easily using the Ascend architecture. So at the bottom of the architecture of Ascend is a concept that we call data planes. And what this is the customer provided compute and storage environment of choice where the data resides and where the compute is executed across all of the data that may or may not or needs to be ingested into the mesh. Just recently, I saw a demo just the other day of our newest Ascend product coming out shortly, where we're sharing data between data planes. So the distribution of data across multiple products, Snowflake, BigQuery, Databricks, for example, is now becoming consolidated into a single Ascend data mesh. This means that the distributed nature of your data no longer requires consolidation to build a mesh in a single platform. You can actually build that in Ascend because we can reach into all of these data planes where the data resides and combine this into a data product, which is what we do in the center part of the architecture. So in the middle of our architecture is a amazing scheduling engine that allows us to apply transformations across different data planes and share data between them, and then build our actual data products that represent your data domains. So if a customer domain exists potentially in BigQuery because that's where your advertising data is, you can construct that product, and then you can take your inventory data, which may exist in Snowflake, for example. You can have that product, and then you can have other products, maybe some machine learning products or whatever that may be in Databricks or Snowflake, and then we can combine all of those in Ascend with a common API to build all these data products together. And then at the top layer, then share these products. So what we're going to see in the rest of the presentation is some of these challenges that data mesh brings to the table. One of which is, how do I actually take domains that are disparate, distributed, and share them and reassemble them into meaningful business deliverables? So just a quick summary: Ascend's data planes crosses multiple compute environments and all the clouds. There's a central place, a central API, a central experience to actually build, construct, build, debug, monitor data products, and then a very clean and easy to use sharing mechanism that allows you to publish your domain data so that the self-service nature of Mesh can come to fruition in a data catalog that you can then subscribe to and create data products with. So the question in your mind, and I know in my mind over the past year or so, has been, why is it that Mesh seems to be gaining momentum? And maybe it's not seeming, it is gaining momentum. And what is it about Mesh that's driving that momentum forward? And how does that relate to maybe our cloud experience with data or a migration from a on-prem system to a cloud system, or from a centralized everything for everybody CRM system to a more maybe distributed data architecture? One of the things that I talk about when I do world tour events and Ascend Labs is that lots of customers come to Ascend because they have a monolithic architecture that's been built up over many, many years. So this looks like a sophisticated dimensional model, or it looks like, an potentially old schema that has been developed over many years. And as it becomes more and more complex, my team is slowing down. I'm less able to maintain agility and meet business requirements in reasonable ways, or in reasonable time. So what is causing me to slow down? And these monolithic architectures have lots of causes for those lack of agility or slowdowns, but these are the two that are top of mind for me. One is bottlenecks get created because we need people with hyper specializations, and those specializations are spread across maybe tools. So if I have a monolithic architecture, I may have some technology or architecture that requires very specific individuals to solve problems. And so this is where you may have an organization, 40 or 50 or 100 engineers, but at the end of the day, you likely have 2 or 3 or 4 people who are the experts in the architecture or in the data model, and they fully comprehend it in ways that they become the central point of work for your org. So all of the work, or most of the work, funnels through these people, and therefore you get a bottleneck, because these folks are the ones that come to all the meetings. They're the ones who can answer the really difficult questions, and your org tends to slow down because the scheduling has to be done by the freedom of these people to work on new problems. They're always in demand, and you can drive deep bottlenecks through very small numbers of people in monolithic architectures. The other thing that I like to talk about from monolithic architecture standpoint is that we tend to have gotten monolithic because we want to manage a single thing and we want this one thing to be easier to manage. So we start out with a really clean, simple model, but over the years, we add more and more things to this model and the model becomes complex. And I'm sure all of you who have seen, a mature dimensional model look at, multiple fact tables, maybe 10 or 15 fact tables, and then maybe potentially hundreds of dimensions surrounding those facts. And so the queries that you have to run to actually pull value out of that model get very, very, very complex, to the point where, again, your hyper specialized people know how to write these queries, but self-service is just not an option in a lot of those times, in a lot of those scenarios. I know that I've personally overseen schemas that had upwards of like 800 tables in the schema. Those are not approachable by normal humans. Like, you need one or two of these superstar people that either understand it or understand where to look. And the amount of knowledge you need to drive value out of super hyper complex models is extraordinary. And that causes you to take much longer time training people. The skill sets required maybe are super specialized. These people are hard to find. And at the end of the day, this stuff all piles up into a much slower progression through project work. So lack of agility is the typical problem. So why is it then that mesh would scale up? So if mesh is going to solve this problem, I'm kind of like a skeptic. So I want to know, like, well, how is mesh solving this problem then? Like, if I have hyper specialization and I'm bringing mesh, why is mesh going to be successful where monolithic models tended to fail? And I think there's at least three really good reasons that we can look at for how mesh is going to scale us up. One is because we're breaking our data models down into product-oriented domain models and pushing the ownership of the building of these domains to individual teams, it means that the overall complexity of the system is going to drop. So the queries that give you potentially valid customers or inventory data or sales information are going to be much simpler because these domains are going to be smaller and more aligned with business outcomes, so that I actually have a chance of, one, engineering at a much faster pace, but two, also decoupling work. So if the monolithic model has a fact that has maybe customer and inventory and SKU and purchase history in it, for example, in the mesh world, those are going to be separate concerns, which are going to be seamed. They're just going to be decoupled or loosely coupled through bounded context, so that I can actually iterate on customer without having to worry about where my SKU information, for example, resides. We can separate those concerns and then accelerate. I can also drive a data as a product mindset much more easily once I've decomposed my data into these business domains. And then, of course, because of the level of complexity is dropping, I actually have a chance at driving self-service. And I'm going to talk a little bit more about this in the future, but self-service is a way to get more fingers on keyboards so that your overall data delivery velocity can improve, or the amount of value you can drive into the business can be much faster because I have more people on keyboards doing more useful work instead of more people on keyboards creating more tickets for engineering. Let's see. All right. So if we're going to do a mesh and we're convinced that, okay, maybe the benefits are real, I am definitely a practical sort of person when it comes to this. So from an executive standpoint, I want to know, how do I know if mesh is working? What am I going to measure? I can only improve things that I measure. So what am I going to measure? And here's three ideas of how to measure a return on investment for mesh. There's multiple ways to do this. It's different for every single customer that I talk to. And whether you get an actual concrete measurement or you need to use a proxy measurement, I mean, I think those are decisions you have to make. And as long as you're making, eyes wide open decisions about that, measuring anything is better than measuring nothing, even if it's a proxy. But let's talk through a couple of these. So if it's true that mesh is going to help us decouple and help us go faster, then I should be able to deliver data products more quickly. So this could look like backlog aging is lower. So maybe projects that took 6 months, if the average time to delivery was 6 months on my backlog, maybe now it's 3 months or 2 months. So maybe I can measure that. Or maybe I can do 3 big projects a year instead of 1 big project a year, for example. And maybe my teams can be smaller and decoupled, so I can work maybe on 2 projects at the same time or 10 projects at the same time instead of working on, kind of the status quo of like, well, I have 2 really good people, so we're going to do 2 projects at once. That velocity should definitely improve. I should also be able to measure how much my domains are being reused. So here we call it data product sharing, but if I have really good quality domains that are easy to consume and are understandable, then it stands to reason that if mesh is working for me, I should be able to see more and more subscribers to these products. So my sharing mechanism should become the entry point for other people who are not engineers to actually start to consume these products. So if I build a mesh and I have the same number of consumers as I had in my monolithic model, and I'm not actually adding more talent to my data space or more analysts or data science people or people who are actually providing the value deliverables to the business, if I'm not improving that posture by more pervasive sharing of this data, then maybe mesh isn't working for me. So if I want this to be true, let's measure it. Let's see how often am I sharing the data mesh. And then I like human centric metrics too. So I think in very healthy mesh environments, meetings should be smaller. They should be fewer people. They should go faster. I shouldn't need to schedule around this, 1 or 2 individuals who are, kind of know everything about this data model. I should be able to get work done more quickly. And one of the side effects of that is less meetings, or number of people in the meetings should be smaller, or there should be some effect in your data environment that shows that people are spending more time delivering and less time worrying about complexity or talking through complex governance things. Those things should manifest themselves in ways that make your environment more agile. So I think if the humans feel like the approach has changed, then the approach is changing. If they feel like, well, now I have mesh and I actually have more work to do and I'm not doing any more work, I'm not getting more value out the door, then there's something wrong with our implementation. So let's measure what we want to improve, and let's have fewer meetings. Let's have fewer people in meetings so that people can spend more time actually delivering work. So these are ideas. Every company, every customer has their own way to evaluate these things. Some are really hardcore metrics. Some are going to be proxies, maybe like number of people in meetings. But however, measuring things is a critical component toward holding yourself accountable for delivering a mesh that actually works for your business. There we go. So again, back to what does this feel like from an organizational standpoint or from an engineering standpoint? I think this squiggly line, in its very simple way, does a good job of describing what the life of a typical data engineer would be in a monolithic architecture, in that the engineer's doing a bunch of work, it's kind of spread out over some time, and then at some point I turn the work over to maybe an analyst or whoever the requester of the work was, maybe a business person, and then that person accepts the work and does a little bit more, adds a little bit more value, and then delivers. So most of the time, this is the workflow that we have for monolithic architectures. And this tends to be the case because the complexities of managing a monolithic architecture are in general more suited to the skill of a data engineer, and the processes of deploying things and maintaining governance and doing all of these things is much more in the data engineering camp than perhaps in the analyst camp. If we move to a mesh architecture, what's going to change? Like, how's it going to feel different? So if we've bought into the fact that mesh is going to be good and it's going to make us more agile, it's going to help us deliver more quickly, it's going to lower complexity, what's going to change in the day of a life of my engineering staff or in my analysts or in my data science. And I think mesh should feel much more like this bottom diagram, which is one, I am a domain engineer now instead of a data engineer, which we'll talk about that in a minute. But regardless, I'm going to iterate more quickly on the asks that I have, but I'm also going to turn the work over more sooner to my analysts and data scientists. So this means that maybe I'm more focused on adding a new data element for some new raw data that maybe didn't exist, and less focused on writing queries that somebody else should be able to write. And because it's less complex, maybe I can turn it over sooner to analysts. And then on the right side, not only am I turning it over sooner, but I'm adding more fingers to keyboards. So instead of an analyst having a request and a data scientist having a separate request and following the upper model, maybe these domains are designed in a way that both an analyst and a data scientist can consume the same exact domain, maybe a slightly different shape, but they can both consume this domain for their own purposes. They can consume it in a little bit more raw status, not raw as in poor quality, but raw as in maybe I'm not solving your first name, comma, last name concatenation problem for you as a domain engineer. You're free to do that on your own in your reporting tool or in your data science Python or whatever you're writing. So I'm going to turn this data over more quickly, and I'm going to have more fingers on keyboards. So I think if the transition to mesh ends up in something that looks like this in your org, obviously you'll translate this into your own terminology and your own kind of people. If it translates in this way, mesh is going to work for you, and you're going to be receiving the benefits of mesh for sure. So if it feels different, it's probably going to be different then. Real quick, and this is sort of a behind the scenes question or reading between the lines, but in the previous diagram here, we changed the term from data engineer to a domain engineer. So what's the deal with that? Like, what is it about that that's important to think about? Some of it's just a semantical change. You're gonna have the same humans doing work, but some of it's not semantics, and I just wanted to walk through that quickly. On the left side here are traditional data engineers working on maybe a traditional monolithic architecture or some Snowflake schema or something, not Snowflake database, but the Snowflake schema. These people are going to have to necessarily have generalist kind of interests and scope and expertise. This is because all of my domains are conflated onto a single model, so they have to understand something about everything to get something done in general. These folks are also a shared resource. So if my top engineer is working on, adding a new dimension to some fact, I'm going to have to then serialize the extra dimensions that I also want to add in the backlog so that they're working on one thing at a time. They're a shared resource. That also means priorities are competing. So if you have a shared resource and you have maybe a business-facing customer thing you want to do and a business-facing inventory thing you want to do, in general, if this scope is driving through these few individuals that understand how to do this work, now you have competing priorities. Which one's more important, inventory or customer? And you have to make these choices. And these folks then tend to drive the priorities because they're the only people doing the work. So you end up making these prioritization decisions. In a mesh architecture, we shift the term a little bit, and we're now calling people domain engineers. And like I said, some of that's semantic, but some of it is not. Some of it is, I want my data engineers to be specialists. So I want the people working on customer data to be experts in customer data, to the point where they're building relationships with their business partners also in customers. And so that the language becomes ubiquitous and the business terms end up pushing into the engineering terms that we use to actually store customer data, so that last name has meaning not just to engineers, but also to business people. Again, driving that self-service demands that the language be ubiquitous so that business terms can be seen in the technical publishing of this domain data. Domain engineers also don't have nearly the prioritization problems. So if you're working on customer data, then my only prioritization decision is which customer piece is more important. I don't have higher level prioritization problems around like, well, I have inventory over here and customer here, so let's decide. No, no, no. There potentially is a separate team working on those things. And so these folks have much less context switching to do as they do their jobs, day after day, week after week. So there are a couple of questions that I get quite a bit around this. One is at the top of the page, like, what's the vision for corporate IT? So if in the monolithic model, data engineers are a shared resource, and they're typically, because they're shared, they're maybe in a corporate IT or a central IT function, excuse me, and I move everybody to be a domain engineer, what happened to my central IT function? Like, where is it? What am I doing with it? And what's the purpose of central IT? The other question I get quite often is, well, I don't have enough engineers to cover all my domains. And that's going to be true too. Like, very few companies can afford engineers specifically for every single domain and fully staff them all and have like little separate engineering departments. So there's still going to be some sharing across domains, or maybe some, if you get creative, some rotations around domains. So maybe 1 month you're working on customer domain, and then you pick up and you move to like shipping domain, maybe as an engineer next month. And so rotation and things are good for training. They're good for all of these things. But the point is, when you're working on customer, you're focused on customer, you're not focused on these other domains. So every company is going to find the right budget and the right way to solve this domain-ish problem. The true to form problem to solve, though, is don't pollute customer domain with shipment domain because you think you're improving your speed by doing that. At the end of the day, that will just devolve back into a monolithic model. So we want to maintain the domain terminology. So I've bought into all this and this sounds great and everything's good, right? So we can just go ahead and do a mesh implementation. Let's go. We're off to the races. So what's the catch though? So if, as everything in architecture, in engineering is essentially a compromise, what am I going to have to look out for as I start to build a mesh and start to go forward? I like to focus on what are the underlying assumptions of the strategy that I'm about to implement. Very often, very, very often, when we go to do things, we fail because the underlying assumptions ended up not to be true for us. So Mesh has some underlying assumptions. And if these assumptions are not true for you, or you thought they were true and you discover later on that they're not, your mesh implementation will likely struggle because of that. So let's talk through a couple of the mesh assumptions. The first assumption that gets made in almost every single mesh publication is that, one, I have technology available to me to actually implement a mesh. And I have data domain experts that can help me define the domains. I think it's very true that lots of companies operate and they have this old data model that works for them. But if you started to decompose that and say, well, which components of customer matter and how do I define a customer in a way that meets a business need and all that, some companies actually don't have the individual around any longer to actually help with that problem. So what am I going to do about that? How do I drive domain driven design if I don't have experts available? So that is a assumption that needs to be true. Same for technology. Data sharing by emailing an Excel spreadsheet doesn't count. So what technology do I have available to me that allows a mesh to become true? And speaking of sharing, I need that capability in order to build a mesh. So if one of the core aspects of mesh is that I build these domains that are loosely coupled, and then I want to couple them together to produce a product, I need to do that in the context of a data share. So how am I going to do that? What's the actual mechanism for that to happen? And then even more deeply, if I'm building a data domain, I need pipelines. I need raw data to enter my system, and I need that raw data to be curated so that I can create a customer, like a customer master or a gold customer copy or whatever terminology you use. I need to be able to take some raw information and curate it into a domain that is mastered. I do that through pipelines. So do I have pipelines available to me? That's a key assumption in mesh. It's kind of like the arrows between the boxes tend to be the most painful parts. These are those arrows. Another assumption is that I have a working governance strategy that I can deploy to my organization. And the key word in this one is not governance, actually, it's working. I need a working strategy. So I can't simply replace engineering with governance to do a mesh. I really need to solve both problems. I need to decouple my data model into these business domains, but I also need to have a governance strategy on top of it that doesn't then replace the velocity that I just saved with governance. Because if my data products are still getting delivered at the same pace after I built a mesh, because my governance strategy is too burdensome or it's overly control oriented, then I'm hurting myself. I'm just squeezing the balloon. I'm moving work from one place to another. So by a working strategy, it's a governance strategy that meets the needs of risk or cost or whatever kind of metrics you use to measure how well governance is working. I need a governance strategy that's going to also be helpful to maintaining velocity. And of course, the major assumption and the most important assumption that gets made by almost all data mesh publications is that every data domain needs some level of maturity. So if you build a maturity model for your data, and then you decompose that maturity model into each domain. So let's say customer domain is in, Salesforce or some CRM tool. Awesome. That's, it's pretty high on your domain maturity scale for sure, because they have APIs, they have ways for you to get data. You can add columns, you can do things really easily. But if I'm running my finance out of Excel, and people chuckle when I say that because lots of billion-dollar companies run their finance out of Excel documents or spreadsheets, that data maturity is not going to lend itself to a finance data mesh domain very easily. So these are problems I need to solve as I enter the mesh world. I need to be aware that some investments are going to be required just to get to the starting line before I can actually do the mesh. So doing a maturity model quickly, back of the napkin, it doesn't need to take forever. You can probably get it done in a couple of days, but a simple exploration into the maturity level of each one of your domains that you expect to build can go a long way toward showing you not only where you should start because the maturity exists, but also highlighting additional investments that you need to make along the way in order to improve the maturity of the domains that you're going to need to care about. So now that we understand assumptions and we're kind of getting to our decision process, we have to make certain decisions before we start to build a mesh. You can't just sort of say, oh, let's go build a domain. There's some decisions that you have to make that are really important and will set your direction for the future. It's decisions that your teams need to react to, potentially get training for, potentially maybe buy some tools or change some architecture. But these decisions need to be made. So if I have issues with domain gaps, I don't have a person who understands how this customer thing works, or I don't have technology, what's the plan? Am I going to hire a consultant? Am I going to defer that work till later until I solve that problem? Am I going to buy something? Am I going to improve something? What do I need to do to bridge the domain and technical gaps? These problems need to be solved if you're going to do a mesh. It's fair to kick the can down the road, but at some point these need to be addressed. Oops. The next decision you have to make is, do I want a standard platform for all of my domains? It sounds reasonable, but if you read data mesh in the truly distributed nature, I could not have a standard platform, and I could have these domains publish from their core architecture. For example, if I have a CRM system for customer, I could have that domain published as a REST API over there, but I have maybe inventory data in some relational database, and I can access the data through some views or some queries. Those are different platforms, and I can still have domains. I can still have bounded contexts. But do I want a standard, or am I happy with different technology or different ways of publishing that data? It's an actual decision that needs to be made. Another decision is, and this may not have been relevant maybe 3 years ago, but now that Ascend is here, you actually can decide, should I buy a platform that can solve some of these really hard problems that Mesh brings? Mesh brings problems like data sharing is tough, security is hard, data catalogs and governance and just describing where my data is hard. I probably have data spread out across multiple databases. These are really hard problems to solve. So am I signing up to build solutions for those problems? And do I have the budget and the time to build those things? Or can I buy a product that can then get me started that much more quickly? And am I willing to accelerate through the investment in third-party tools and then focus more on the design of the domain and less on the mechanics of publishing that domain, curating that domain, pipelining that domain, and doing all of that work? And there's no right or wrong answer here, because maybe there's a combination of tools. Maybe there's some things that are really well established and some things that are old and needs to be replaced. There's a spectrum of solution here, but asking yourself, should I build it or should I buy it, is a legitimate question that needs to be thought through for sure. So one of the most difficult parts of Mesh, if not the most difficult part of Mesh, is how do I actually share the data from different domains? It's very typical in this diagram here that perhaps marketing data is in BigQuery. That's where maybe my clickstream data lies. So I have all of my digital products, all of their clickstream data is there. So that's a really big domain. It's probably not practical to pick that domain up and move it. I'm probably going to leave it there because that's where it belongs. But then maybe my lines of business and finance are in Snowflake because I either have tools there or I've adopted that for various reasons. And then maybe a couple of lines of business, either through acquisition or because they have data science things, or for whatever reason, they also exist in Databricks. So my data is spread out amongst all these domains. Prior to Ascend, the sharing capability could, in general, only be implemented by consolidating those domains into one platform. Pick one, BigQuery, Snowflake, Databricks, whatever. You need to consolidate that data. That means build ETL or build pipelines to pull all that data together and then share it as a monolithic data set. So either through your BI tool of choice, or through data feeds like data outputs, or through queries that you run out of a central place. Ascend recognizes with our architecture, though, that we can actually take the pipelines, not only do the pipelines in each one of these native tool sets so that you're not paying unnecessary egress costs, for example, across these different tools, but we can also combine the outcomes of those pipelines, and those pipelines being data products, which are domain data. We can combine those things across all of these platforms in a live way so that you get the best of both worlds. One is I can leave the data where it resides. I can pipeline the data on the compute of where it resides, but then I can combine these domains together into a data product that then I can, choose which platform to do the compute and storage for this data product on. So if I want to build it in BigQuery because most of the data is in BigQuery, that's awesome. If I want to build it in Snowflake because that's where my BI tool is pointed, that's awesome. If I want to push a data product out to some machine learning in Snowflake or Databricks, I can do all of that work also. The point is that Ascend brings all of that together behind a common API that lets you share data across these tools. So building a multi-data plane product is a real thing that you can actually do right now in Ascend. The live data share is a real thing in that schemas can propagate, data can be updated, and that can all be managed across live data shares. So if you're considering building your own tool, consider that this problem is the hardest, potentially the hardest problem to solve. Not only because the data that you have is likely distributed amongst multiple systems, but also because the APIs are different across all of these tools. So you're going to be building your own common API across it, or you can use a Ascend's API that's standard across all of these tools. So I just wanted to point out a couple more Ascendish things before I turn to a couple questions that popped up. In Ascend, when you're using Ascend's, not only UI, but also our SDK and potentially our CLI, also creating new shapes for existing domains is super easy. You can create them and publish them just in minutes. As long as you can write the query, you can then turn around and publish that information and make it available. So all of the hard complexities of that are much simplified in Ascend. Not that the queries are restricted at all, but the complexity of delivering that data in a shareable way with security is taken care of for you. The subscription activity. So if the opposite of publish is subscribe, because I want to pull the data in, it literally only takes a single click to subscribe to new data in Ascend. And that would be across data planes too. So if the pipeline resides in Snowflake and you're in Databricks, you can subscribe to that data as long as it's published from the Snowflake plane. You can subscribe to it in your Databricks plane and go about your business. The other 2 points, staying productive is key. We are adamant at Ascend that your org should scale in terms of data seamlessly, essentially, without having to worry about your organization slowing down, and stay productive no matter what data scale you have. So if your data were to go up by 10x tomorrow, if your org would have to react in a certain way, we view that as a negative. We think automation through Ascend will help drive your productivity, keep your productivity flat as your data scales, essentially. And then, of course, sharing products and sharing data in Ascend is super easy in seconds. This is a little view of the UI. Before I go and do a quick demo, though, I did have a couple questions that came up. Let's see. How does Ascend handle composite and consumer aligned domains? So I believe by Randy's question that a composite domain would be potentially a domain that contains more than one piece of information in it across domains. Ascend allows you, and I can show you this in the demo, you're free to build the pipelines how you need them across different domains. So if your composite customer includes not just the customer demographic, but maybe customer financial information, and you're creating a composite customer out of that, in Ascend's world, that's just another pipeline. It's another shape. So whether you choose to call that a separate domain or an extension of an existing domain is sort of semantically up to you. But we make it possible to then take that raw data and combine it and share it however you see fit. So we have almost no opinion on how your domains get built, other than our opinion is you should build them in a way that is simple and easy to document and are consumable. But how you assemble the raw data is a business choice that you're going to have to make. I'm not sure where consumer aligned domains would be, but maybe that's different shapes of existing data that consumers would use. So if a data science person wants a different shape of data versus an analyst wants a flat data set to put into a report, both of those shapes can be produced really simply in Ascend. Again, I can show you in a quick demo how that would work. And then Rothio asked, in my opinion, what role do leaders and managers play in fostering mesh architecture? I think that's a really relevant question, which I didn't handle here. But the short answer is leaders and managers will make or break the mesh culture. And the two things that really need to be true is, one, you have to watch out for polluting domains as you mature them. The organization will tend to want to revert back to a monolithic architecture because that's where the organization came from. So managers and leaders need to be on the lookout for shortcuts that look fast but end up polluting domains so that you end up with a messier architecture in a few years from now. They really, you should avoid. So I think leaders and managers can go a long way toward improving that in the governance strategy and making sure that there's architectural checkboxes. And then also making sure that engineers, analysts, data scientists have the time to focus on actually producing good quality domain data and then combining that domain data into really good quality products and fostering that freedom to build the right thing for the right consumer through that product mindset. So we only have a couple minutes left, so I'm going to jump to a quick demo. So what I have here is the Ascend product. If you've never seen it before, Ascend has a nice UI. Here, the purple boxes are actually data feeds, data shares that are coming in. I happen to be using Snowflake for this demo, but the red boxes are all transformational activities. So if I'm looking at this is the data consumer view of the world. This particular pipeline is maybe an analyst who's trying to calculate taxi ride information with weather data. So they've subscribed through our data catalog here. They subscribed to some weather data and they subscribed to some taxi cab information, and they've built 3 data products here. So one is a little snowpark job that calculates the average tip and average fare amounts based on the type of weather and the date. Apparently that was important to them. And then they've also produced maybe a flatter list of detailed information about taxi cab rides in nice weather days and then rainy weather days. So this would be potentially 3 data products that have been created. And you can see these are different shapes. So these 2 may have the same schema, but they're different data. And then this one has this particular transformation has a more restricted content, maybe for some other purpose. And it's really easy just to create transforms. I can just create new transforms as I see fit. The entry criteria being, if you can write SQL, you can use Ascend. So I can create this, Ascend can automate it, and you're off to the races. Let's look at the left side, which would be more about creating the actual domain data itself. So if I look at the publisher for this data, so this is the data flow. Zoom in here. This is the data flow that reads in raw data. So you see a teal box here. So this would be raw data entering the Snowflake system in this case, where I have some weather station name information and raw API weather data. So this is raw data that gets cleaned up into the amount of precipitation and the date and maybe the station ID and the type of rain. Is it snow or rain or whatever? And then I'm combining that with some station information to produce a schema that, as a domain expert in weather, that I like. So I have some weather data here. I have a weather station name. Apparently we've added a test column, and we're good to go. So one of the amazing things, 2 amazing things about Ascend. One is then I can just share the data because I have this particular schema, and I can share the data with a data feed. And this data feed then essentially puts it into the catalog that builds the subscription model. So as I build a domain, I can share it, and I can share as many different places as I want. I can create a new data feed here, for example, if I want. So I can now share just my weather data, and I can share my weather and station data really easily. But one of the most amazing things about Ascend is the level of automation. And this is back to, if I'm building a mesh, how am I propagating change through it? How am I managing governance and all those types of things? But I'm going to change a business rule here. So instead of a 1/4 centimeter of rain being a rainy day, I'm actually going to have it be more rain to define a rainy day. So it's got to be 1 1/4 centimeters of rain to be a rainy day for whatever reason. So I'm going to make that business rule change. And you're going to see that Ascend is going to propagate that change, not just locally through the data shares, but also downstream here. So imagine I'm crossing data planes and now I'm in Databricks. I'm getting my updated records all the way into Databricks, essentially in an automated fashion. And then my 3 or 4 now data products down here will also receive the updates. So if I have reports tied to these, or I have graphics and things tied to this, all of those changes will propagate downstream then with the Ascend automation platform and become updates to me. So as an analyst, I know that when engineering things change, I will receive the updates if I've built my mesh using Ascend. You'll remember that Ascend builds our software across layers. Those layers lend themselves to really, really nicely to mesh implementations across multiple data planes, across multiple clouds. So I appreciate you joining today, and feel free to reach out with any questions with all of our contact information.